The software has a tool called Experimenter. And what it does is it takes a look at the code that you're generating between your 3D model and your process flow. So you can look at the core code, give you a chance to run a number of different scenarios, but it's not doing any of the thing with the 3D model. It's not moving tokens around on the screen even. It's just doing it all in the background. So it runs much, much faster. That way you can develop your scenarios that you want to try and see what the benefits are. So then you can decide what is it worth you spending your resources on. Because if you're like most people, you do not have infinite resources, whether it's time, money, space. You're going to need to pick something. I have this nasty feeling. Oh, good. Phew, I thought I'd opened the wrong one. Okay. So as I was saying, I could go ahead and run this. And I hadn't talked about what the kind of reports I could do. These are live reports to see what's happening. Oh, I was still down at the 4 times real speed. Let's just get that up and get that moving a little bit for things to start happening. Yeah, we're running 300 times real speed, so that poor person is just going nuts. But you can see the mix that's taking place, how they're getting put into the queues, and then going through the process, so the results of the process then put them into a different queue, which then feeds into, this is called a combiner, essentially loading up the palette with whatever the given order needs. And we're keeping track of how many pallets per hour we're doing, and we're up in around 4.5 or so pallets per hour, sometimes spiking up to 5, sometimes dropping lower, but it looks like it's in that somewhere between 4.5 and 5. Okay, so let's call that our baseline. And our baseline is we've got one person doing all the work, we've got one machine, and we've got a failure rate we're assuming of 20%. So that is an assumption that we're working with. Well, as I said, we're pallets per hour, and you can see this number is changing. It might be an eye chart to see on your screen, but that is definitely changing. It's up in the 4.6, 4.7 with a little bit of a bump up and up in the 4.9s. Okay, and the operator is about 62% utilized. So even though it looked like they were going a mile a minute, that's only because I had the speed 50 times what you would normally expect. So let's stop that. Give them a little bit of a break there. And I'm going to run something called Experimenter. Experimenter is taking a look at my model and what I've identified as parameters. That was the same as what we just saw in that tab there. The team size, 1 person. Well, let's see what happens if we make it 2. All right. Number of machines. Failure rate. And then let's see what variations. Double number of people, keep everything else the same. Go back to the single person, double the machines, so on. Okay. Granted, on this system, that could have been run fairly quickly, but it still would have taken some time, and I have to note that down. So what I'm going to do instead is I'm going to say we'll give everything a good hour to get up to speed, and then we'll run it for another 10 hours from there. And for each one of those each one of those scenarios, we'll run through 30 tries, because we've got some statistical distribution. We got some randomness. Let's see what the randomness does to the results. Not just take a single data point, but let's see 30 data points for each one of these scenarios. Now, I'm going to go ahead and delete the results because I did that before. There's the 4 scenarios it's going to run. I only have one experiment set up. I'll go ahead and run it. And you'll see, okay, everything's been primed, and now it's actually running them. And I would say it's a little bit faster than I would do it by hand. Or, sorry, not by hand, by changing each one of those parameters and doing another batch. And especially it's running faster than if I was going to do each one of those and then try and analyze the results. So what I can do here instead, I'll pull this over a little bit and make it a bit bigger, is here's what we started with, and gee, we had a median of 6.1 pallets per hour. And between 25% and 75% of them, there was my range in that. And my total range, we had something up there at 6.9, and we had something way down at 5.3. So fairly tight, typical. Oh, we had a team member. We'll have some time where apparently that team member's not really helping. Boy, we'll run sometimes when it does, and overall, we're now up around 6.5. What if we only had one person, but we added a second machine? Oh, interesting. Same median. What if we paid a little more money to get some better quality raw material coming in? Or somehow we're able to do some rework on the front end to clean up any possible failures? What if we took that failure rate from an assumed 20% to assumed 5%? We get a little bit better there too. So each one of these scenarios, there's a cost associated with that. I have a chance to decide which one I want to do. Now, when I first looked at this, I went, which one do I want to do? Well, this is something maybe I could do as early as next week, bring somebody else in, train them, get them working. Adding a machine, that could take a month, could take a year, could take 5 years. Reduced failure rate, that would be ongoing negotiations, maybe if it's coming directly from a supplier, or maybe it's a front-end process, or maybe it's a way of tweaking our overall process so it's a little more forgiving for any things it finds, but that one's probably going to take long term. Which should I do? Well, maybe instead of just looking at where all the different 30 individual runs went, maybe I should take a look and see how they compare. So from the baseline, we definitely got some improvement. Statistically speaking, we got some improvement in all 3 of those. As I mentioned, probably adding in team members the quickest, easiest. There is money involved, definitely, but it's the quickest. Is it any better than the other 2? No. So really, from an overall output point of view, this simulation says that it doesn't matter which one of these I do, I'm going to get the same improvement. So maybe that tells me I would go and add a team member for the short term, maybe for 6 months or so, while I work on something overall to get my throughput up where I think I'm going to need it. And that's the power of the experimenter. I can do those what ifs. I can do them very quickly. Here's a what if. I'm sure this has never happened to anybody. The boss comes over and says, well, what if we take a look at a different way of doing it? And of course, the right answer is yes, sir. So let's say that this is all of the above. No, that's kind of silly because he's not going to want to spend the money on the equipment that's not going to arrive for 6 months. Let's just say plus operator and reduced. I can type today. I'm just going to say FR for failure rate. So let's say we do 2 things. I'm going to make that be 2. I'm going to say, maybe I can get that down. Maybe I can cut my failure rate in half. Negotiations, whatever. Okay, I've got a brand new scenario I want to run. Do it for the same 30, the same settings here. Sounds good to me. I don't need to delete all those results. Here's my scenario I haven't run yet. I'm just going to go ahead and run. And it's going to look and say, that's the only one that actually needs to go through the system. There, we're done. Did I gain anything? Sir, it was a really good idea, but the model just doesn't prove it out. it really by itself didn't really seem like it helped enough. Why don't we just go with adding the team member and see what we can do from there? Are you sure? Well, yeah, yeah. If the model that I built is an accurate representation of what we're doing on the plant floor, then yeah, I'm sure. And I do want to leave you with that thought, just like any other simulation, whether it's stress analysis, whether it's circuit analysis, uh, any kind of simulation, you're doing just that. You're simulating the real world. So it's going to be as good and as bad as the care that's put into that simulation. All right, I always feel I need that disclaimer, having watched people with stress analysis. Oh, this will never break. No, that's not how you interpret that.